Okay, hello everyone. Thank you so much for joining us for today's spotlight. Today we're highlighting the Aerospace and Mechanical Engineering Master's Degree programs, and we wanted to introduce you to Professor Paul Ronney, who is going to provide insight about the master's programs in Aerospace and Mechanical Engineering. My name is Erin Tanaka, and I represent the Viterbi Admission and Student Engagement Office. I'm also joined today by my colleague Marilyn Lau, who will be available to help answer questions from the audience as well. So we're going to go ahead and get started. So just a quick note, for those of you that are joining us today for today's live session, I will be sending a follow-up email within 1 to 2 business days that will have the follow-up presentation slides. So no need to jot down anything right away unless you need that immediately. And in addition, throughout the session, if you have any questions, please use the Q&A to the right of the panel. That way we can see your questions. However, I just wanted to also let you know that we are going to wait until the Q&A session towards the end of the session to answer those questions. That way we can make sure that we get through all of the material for those that are going to also be watching later on during the recording. So for today's program, we will start out by talking a little bit about the University of Southern California, USC, and then the Viterbi School of Engineering. I'll give an overview of that. And then we'll have Professor Ronney discuss our Aerospace Mechanical Engineering master's degree programs. And then I will discuss the application criteria. We'll go over the enrollment options, including our online Jenna Viterbi delivery method. We'll also briefly go over tuition and funding. And then at the end of the session, we will have, you will all have the opportunity to ask questions of Professor Ronney and any other related questions as well. So just some snapshots of our beautiful USC campus for those of you that are not familiar. And a little bit about USC. So we are the oldest private university in the Western United States. We were founded way back in 1880, and we have over 49,000 students. And as you can see there, our graduate student population actually outnumbers our undergrads. So our graduate students are a huge part of the USC campus. And we have over 4,700 full-time faculty members that have a variety of different interests and backgrounds, of course, passion that they bring, and many of them bring their expertise, whether it is outside of the classroom in industry or their research knowledge as well. We have a very diverse student population, so students from all over the country, all over the world, all different walks of life. And we're located in Los Angeles. So for those of you that are not, familiar with Southern California or the Los Angeles area, we are about a 10 to 15 minute drive from the downtown Los Angeles area. So we're really in the middle of all the action, whether, of course, it's the entertainment, the arts, but also at the same time, of course, opportunities for whether it's internships or career opportunities in engineering and the technical field. We are also well positioned, not too far from the Silicon Beach area as well, which has many different opportunities. But beyond, Southern California and Los Angeles, USC is very well known to have fantastic connections with numerous, companies and organizations. So, the many opportunities that our students have are just limitless in that sense. And in terms of the Viterbi School specifically, so we are one of the oldest and largest schools within academic schools within the larger USC campus. So we are comprised of 8 academic departments. Of course, our aerospace mechanical engineering being one of our most prominent departments out there, and Professor Ronney will discuss that in a bit. Our student population, we have over 6,300 graduate students. And so as you can see there, that's essentially double that of our undergraduate population. And so again, our master's students, both online and on campus, PhD students, grad certificate students are a huge part of the Viterbi School. And then, we are a leader in funded research. So we have over 35 research centers, which we'll also discuss in a bit. In terms of our faculty faculty members, we have 189 tenure track faculty. We have 33 National Academy of Engineering members, which is, one of the greatest honors you can receive as an engineer, and over 90 National Science Foundation Career, National, and Presidential Young Investigator awardees. But for today's session, we're going to highlight Professor Paul Ronney, who is the professor and chairman of the Department of Aerospace and Mechanical Engineering. So he actually earned his Bachelor of Science in Mechanical Engineering from UC Berkeley. He has a Master of Science in Aeronautics from Caltech, and then a PsyD, or a doctoral degree in aeronautics and astronautics from MIT. So definitely lots of education background there. Of course, beyond that, he has experiments with flying experiments flown on 3 space shuttle missions. He's published over 80 technical papers in peer-reviewed journals, over 250 technical presentations, 7 U.S. patents. He's a fellow of the American Society of Mechanical Engineers and the Combustion Institute, and he's also the associate fellow of the American Institute of Aeronautics and Astronautics, as well as a recipient of the National Science Foundation Career Award. So Professor Ronney, thank you so much again for joining us today. So I'll go ahead and let you take over. I do want to mention though, really briefly, that the presentation materials are as of today, which is April 12th, 2022. So for those of you that are going to be later on joining us or watching this recording, just take that into consideration, especially regarding the curriculum and the application requirements, as they can change. But take it away, Professor Ronney.
Okay, thanks very much. So first of all, some of our major research. First of all, congratulations. On these are, remind me, these are accepted or these applicants?
These are prospective
Applicants.
students.
Okay.
So
All right.
hopefully
Okay,
in the future they will be admitted.
Okay. Okay, congratulations on your future acceptance to the program, and congratulations on coming, this far to find us, and we appreciate that. In terms of our research focus, recently, this is my second year as chair of the department, and we went through a strategic planning exercise, and we identified 4 major research themes that we wanted to pursue: robotics and autonomous systems, energy and sustainability, design and manufacturing, and medicine and bioengineering. And above and that, sort of cross-cutting themes across all those areas and everything else that we do. One is artificial intelligence and machine learning, affectionately known as AI/ML, and also aerospace systems. Remember, we're in the center of the world's aerospace industry right here, so we want to be responsive to the needs of people of the industry that will employ many of our graduates. Okay, let's move on. So in terms of, now I'm not talking about the School of Engineering as a whole, but the Department of Aerospace and Mechanical Engineering. We have 34 full-time faculty. Of those, 8 are teaching track, 1 is research track, the other are all tenure track. We have on the order of, almost 600 undergraduates, similar number of master's students, and about 100 PhD students, and something on the order of $25 million of active research funding. I mentioned a few of our student groups. Most, if not all of them, are open to master's students as well as undergraduates. I like to highlight our aero design team. They compete every year in the American Institute of Aeronautics and Astronautics Design, Build, Fly competition, and we have won the national championship 3 of the last 7 years. So what Alabama is to football, we are to this AIAA Design, Build, Fly competition. We also have a very robust program, the Formula SAE race car team. As you can see there, we have both a combustion engine team and an electric team now. We have a great facility in the new Baum Family Makerspace that you may have heard about. We also have a number of other teams, a human-powered vehicle. We have what we call Aspen, which is basically looking at nuclear rocket propulsion. Now, we don't actually have a nuclear reactor on campus, but they look at the looking at the fluid mechanics and heat transfer that are associated with those efforts. And just recently, in the picture in the upper right there, a couple of months ago, NASCAR actually built a track inside the Los Angeles Coliseum, just across the street from campus here. That's where our football team plays. And they actually built an entire racetrack in there. And they invited our team to drive the track before any of the NASCAR teams did. So for 2 days, we actually held the course record, of course, until the NASCAR cars showed up. But in any case, so as I say, very robust student design teams. Not those master's students, especially those of you that would be taking your master's degree remotely. You may not be able to get involved in these things as much as you otherwise be able to. But there are even opportunities, even for remote students, to get involved in these. Because, for example, all these teams need a lot of computational simulation, for example, of the race car, of its aerodynamics, of the flight dynamics of our design build fly competition. So there's a lot of opportunities even for students that are not physically present on campus to get involved in these activities. Okay, let's move on. So we have a number of master's programs. We have just a sort of garden variety aerospace engineering and mechanical engineering master's degrees. Then we have specializations in computational mechanics, dynamics control, energy conversion, product development engineering, engineering management, again, dual degree, either on the aerospace side or the mechanical engineering side, between the engineering as well as management. Okay, let's move on. Okay, so the requirement is minimum of 27 units. Some of our graduate courses are 4 units, some are 3 units. So if you do the math on that, if you're taking all 4-unit classes, then you take 7 classes, but one of them could be a 3-unit class. Our undergraduate program is primarily 3-unit classes. There's some 4-unit classes, but mostly they're 3 units. And we may be changing that this coming academic year, but well, it would be the following academic year, not this coming one. So we may shift the undergraduate curriculum as well. But you can take up to, I forget the exact number, I think it's 8 units or something like that of 400 level classes towards your master's degree. And then again, above and beyond that, there are, and one required course required of all master's students is an applied math class, which we call engineering analysis. Again, a number of additional units of just within AME 500 level courses. And then again, the remaining units adding up to 27 can be from this approved either senior level, undergraduate 400 or graduate 500 level classes. And then above and beyond the specific majors that was mentioned on the previous page, there are a number of specializations. These are just sort of suggested routines. It doesn't change like what's printed on your diploma or anything like that or in your transcript, but these are just things that you can emphasize because usually most master's students, they have one particular interest in mind. So they're focused towards, let's say, one industry or one type of job within industry, and you can specialize in that. So I see a question up here from Michael. Is there an application process to get involved in the student groups? For most of them, no. You just say, I want to be a part of the group and show up. The main thing is, participate. And like all these student groups, they have faculty advisors, but they're primarily run by the students. And so, to get involved, you show up and, say, okay, I want to work on such and such. Do you have some part of the project involved in that? And then the leaders of the group will say, okay, you work on this. And, the leaders have experience in this and they'll see, well, do you participate? Do you, follow through with the assignments? And the more you do, then the sort of higher up you can move within that group, take on more and more responsibilities. Okay, let's move on. Let's see. Anything else? So you mentioned, okay, so Master of Science, Mechanical Engineering, again, the same basic requirements, and again, a number of optional specializations which there's sort of a list of courses that you can choose from. But again, you don't have to follow any one of these particular specializations. It's just a suggestion. Again, as I said, many students come in with a particular specialization in mind. One thing I would, so this is a bit of a sidebar topic, but one thing I would like to mention is that I think the most underutilized resource on campus are faculty members' office hours. Let's suppose you come in as a master's student, you're not really sure which of these specializations you're going to be most interested in. You're not sure what type of industry you might want to work in. You might sure maybe you want to go on for a PhD, or you're not sure about that. Go and talk to faculty members during their office hours. There's nothing we love to do more than to talk about the things that we're passionate about. Now, for myself and like the other faculty, we tend to give priority to students in our classes, particularly when there's homework due or an exam coming up. But above and beyond that, I'm always available when I have office hours. Unless I've made prior arrangements, I'll be there in my office. And in the past year, it's been physical as well as virtual. And we love to talk about the things that we're passionate about, whether it's trying to help guide you in terms of what you might want to specialize in, where you might look for internships or summer jobs, or if it's even in my particular case, uh, my expertise is in space, and it's in energy and combustion. So we're more than happy to talk about those things. I would even say take it one step further. What if you're interested in some 18th century French author? You're saying, well, wait a minute, I'm a graduate student now, but and I should focus on this. But there's nothing wrong with going. There's probably somebody on campus who's an expert on that 18th century French author. Find out who it is. Find out when their office hours are, and go and get that faculty member's, expertise and perspective on that author. You'll never have this opportunity again to have access to so many experts in so many different areas, all for free. I guess I shouldn't say for free. You're paying for the tuition, but for no additional charge. Let's at least put it that way. Um, another question from Julian, are there virtual office hours for students in the online master's program? Oh yes, absolutely. Because we know that a lot of our students are participating virtual, even, the ones that are on campus, either because, it's just not convenient for them to come to campus, or sometimes they might be feeling sick, and so they don't want to come to campus and possibly infect others. So I always have hybrid office hours. I mean, and I think because of the the remote masters population, that I'll probably continue to do that. We have a great conference room just down the hall from us. So I find it very convenient to hold office hours there, because then there can be a group of students, present in person. And then with the big screen TV, I can see the remote participants as well. What always happens in those, and it's really a good thing, is that I'll be talking to some students about one question they might have on the homework, or something that might be coming up on the exam. The other students, are not as interested in that. Maybe they understand it, and they'll start talking about something else. So we'll actually start usually 2 or 3 discussion groups running simultaneously within office hours. And I really think is very important. It's very important that you work both individually uh, when you study, and in a group, because believe me, as much as you think you understand something, you really don't understand it until you have to teach it to other people. Trust me, I know this from long experience. So I sort of actually like these hybrid office hours. Anyway, just moving on. So then we have some specializations. You're not going to be quizzed on this, so and you'll get access to all this information um, later on. But so here's an example of just one of the particular master's specialization, computational fluid and solid mechanics, which then has a number of required core courses, most of which are in AME, but some, you see, one is in civil engineering. Uh, and then there are a number of elective courses you can take above and beyond that. And as well as some additional electives, in this case, in the area of fluid and solid dynamics, and then another in the area of numerical methods. Because more and more engineering is simulation. In fact, even for my freshman class, I teach them to build bridges like this. But they don't just sort of say, oh, this looks pretty. What we do is they learn the basics about statics and strength of materials, bending of beams, things like that. They've also learned how to use CAD, computer-aided design programs, and the finite element analysis so they can do the structural analysis. Now, they don't understand the detailed workings of the finite element analysis code, but they at least understand how to use it. So when they design this bridge, it's not just design looks pretty, it's one that is the most functional design that they can come up with. And then we 3D print them for them, we test them physically, and then they compare the actual test results to their computational predictions. And that's how a lot of engineering goes nowadays. It's first, specifications, is, come up brainstorming, CAD to design something, simulation, before, and then usually the first prototype you build is with some sort of additive manufacturing 3D printing process. And only then do you test your physical design. And then you may do a couple of iterations. In this project, we have time for one iteration on that. They can have a test bridge before their final bridge. Okay, let's move on. And so I don't think I have to go through in detail all of these different options, but I just want to show that you have, okay, dynamics and control is another option. The way people say, well, what does it really mean? What does controls really mean? Nobody likes to be controlled, right? But what does that mean in the context of engineering? The way I like to think of it is this. Now, according to the laws of mechanics, I can balance this pen on its point. All the laws of statics, that is, the sum of the forces equals 0. And so wait a minute. So how come it keeps moving? No matter what I do, it keeps moving. That's because it's an unstable equilibrium. That is, if it's perturbed slightly one way, it keeps going that way. So I have to be able to respond fast enough, and I'm not able to respond fast enough to be able to keep it balanced on its point. So it's an inherently unstable system, and my personal control system, maybe yours is better than mine, is not able to control this and keep it balanced on its point. And that's what control systems are all about, is stabilizing inherently unstable systems. For example, in aircraft, high performance aircraft, are inherently unstable. Even the best pilot in the world cannot control it without this control system, computer controlled control system, to do the task. Okay, let's move on. And then energy conversion, of course, that's my specialty. So you learn about fundamentals of combustion and various types of energy, non-combustion forms of energy. And then you can specialize in, like say, propulsion or a number of other, energy-related topics, heat transfer or fluid mechanics. All right, let's move on. And again, product development engineering. We have, this is in collaboration with industrial and systems engineering. And there are a couple of sub-tracks within that, either in product development systems or product development technologies. All right, let's move on. And then, if that isn't enough for you, we have a couple of dual degree programs, as is it either with aerospace or mechanical engineering with engineering management. And now this is not no longer the 27 unit curriculum. This requires almost, but not quite, double the number of units to get, actually 2 separate degrees. And then you will have 18 units in a total of 48 units. So again, almost double. Then you'll have 18 units, in aerospace mechanical engineering. And then again, some combination of 400 and 500 level courses in aerospace mechanical engineering or industrial systems engineering, approved by the advisor to form some sort of a coherent theme. And again, no more than a certain number for this program, 15 units at the 400, the senior level. Okay, let's move on. Okay, and so you might say, well, okay, what happens when I graduate? Where do our graduates go? And they go to a lot of different places. We have career fairs, and we have a wonderful career services staff. But where do our students wind up? A lot of our students wind up in the local aerospace industries. Let's go on to the next page. I think there's some more about that on the next page. So we have the local aerospace industries in orange. They're Boeing, Northrop Grumman, Lockheed Martin, Raytheon Aerospace Corporation, SpaceX, A lot of our students go to SpaceX. Sometimes, that Hyperloop system that Elon Musk wants to build. I think the first one should be between campus and SpaceX, which is about 10 miles to the south of us, because we send a lot of students there. I know when I visit there once in a while, walking through a hall, say, oh, hi, I haven't seen you in a couple of years. Oh, I remember you from such and such a class. There's a lot of our students go there. Then there's a number of um, other places, Scaled Composites out in Mojave. Okay, there's SpaceX, AeroVironment. These sort of more, the smaller non-traditional aerospace companies. Some will go to work for the government labs. I have a number of students working at JPL or Edwards Air Force Base, NASA Ames up in the Bay Area. And we have a lot of students going into um, consulting, financial or legal industry. Frankly, a number of my best undergraduate students. I remember the two best graduate students, undergraduate students I ever had in terms of classroom work. Both of them took three of my classes, and in all three classes, they didn't just get the highest grade in the class, highest total score in the class. They kind of blew the top off the curve. Both of them are now patent attorneys. So, number of people, and sometimes students will say, well, I really enjoyed the engineering, but this is kind of where my heart lies, and they're almost apologetic. And I say, hey, you know, this is a university. The route is universal. This is where you try everything and you find out what you're really passionate about. And they found that the legal profession was the way they wanted to go. I'm very happy for them. I also think in terms of consulting. I remember one student I had. She was in my freshman class. And I learned from her that she was what they called a Norman Topping Scholar. This is only for undergraduates, so won't stick on this topic too long. But there is a fund that students pay into as part of your fees that pays into a special fund to support a small number of students from the local community who cannot afford to come to have or qualified, but can't afford to come to USC otherwise. And she was one of these local scholars. I found out that she was not only the first person in her family to go to college, she was the first person in her family to graduate from high school. And she's now a consultant with a high-powered consulting firm in the Bay Area, probably making more money than I do, but okay, that's fine. She's doing extremely well in that area. And then some people, I don't know why this is here. UCLA, is that a four-year school? Do they have a football team or anything? No, I mean, frankly, we collaborate. Of course, we compete, in the athletic events, but in academics, we collaborate a lot. I have a lot of collaborations and a lot of great colleagues over at UCLA, as well as Caltech. All right, let's move on. Oh, I guess I should say also, a number of our students work in the entertainment industry. Like one of my recent graduates, she's now working for Disney Imagineering. It's just one example. All right, let's move on.
Okay,
Okay.
well, thank you so much, Professor Ronney, for all that detail and insight. And now I'm going to actually move on to the application criteria for our master's programs. So, an undergraduate degree in engineering, math, or hard science from a regionally accredited university is required. So during the application process, you would actually submit copies of your transcripts from all of the post-secondary institutions you attended. And then to be competitive, although it's not required, we do recommend a 3.0 and a 4.0 scale, but again, it's not required. There are other elements of your application that we also take a look at comprehensively. And then in terms of the GRE, so the GRE is not required for admission to our Viterbi graduate degree programs, including all of the master's programs, your aerospace and mechanical engineering. So definitely for fall 2022, and I'm going to go through the application deadlines, but you do not need to submit those scores, and it would not negatively impact your application in any way. The resume and or CV is required, as well as a personal statement. And then the area that's going to depend the most based off of individual programs are going to be letters of recommendation. So Some programs it's optional, others they may require a letter or two. So it's very important that you are actually consulting the individual program pages and the application criteria for those particular programs. Also, again, keeping in mind that the criteria can change over time, so it's always really important to reference our website, especially if you're watching this later on as a recording. In addition, the TOEFL may also be required for international applicants to demonstrate your English proficiency as well.
If I could jump in here for just a minute, uh, a couple of suggestions about
Mhm,
your personal statement and letters of recommendation. For personal statements, please do your homework and make your personal statement specific to USC. I
mhm,
get letters all the time, or I read personal statements all the time that says, I would like to attend New Font, University of Southern California, back to the old font, because you have great faculty such as New Font, Professor Ronney, back to the old font, and you have great, research in New Font. Again, it's obviously just, a generic letter with a few copy and pasted buzzwords. Needless to say, that kind of turns us off to your application. So do your homework, make sure you understand what we offer and what we can do for you, what you can do for us. Because one thing I should say is I was a student at 4 different universities and on the faculty in another university before coming here, and none of them really had much of a sense of family. And so when I came here and people were talking about this Trojan family thing, as I'm sure you've heard before, my first reaction was saying, okay, whatever you say. But I quickly found that there really was something to it. You know,
mhm,
becoming a member, of Viterbi, you are part of the Trojan family. And so you should put in your application, particularly your personal statement, what can the family do for you and what can you do for the family?
mhm.
So make your personal statement actually personal and not generic. Also, on letters of recommendation, I've read letters of recommendation from, you know, letters of recommendation should be from from faculty at whatever your undergraduate institution, or if you did a summer internship with a faculty member at another university, that's fine. Sometime from employer, it's okay, but again, the academic life is quite different from the corporate or industrial life. So unless unless you were working in sort of a research environment, and particularly if your supervisor has a PhD, those are okay. But primarily, we like to see letters from other academic flags. After all, you're applying for an academic position, not for an industry job. But I've actually read letters of recommendations from clergymen, from athletic coaches, from graduate students, people that really doesn't help us to understand how well qualified you are to become, to join the master's program here. So please make the bulk of your letters from um, people in academia, or maybe, again, as I said, maybe one letter from, let's say, an employer. Again, if it's in a sort of research or semi-academic environment, someplace like Aerospace Corporation, which is, a semi-private organization, but they're very research focused.
Perfect. Thanks for that additional insight, Professor Rani. That's really helpful. Great. All right. And so in terms of the application deadlines, so for fall 2022, we actually extended the application deadline. Now, this is only for those that are planning to pursue their program fully online via Dana Viterbi. So we did extend it to May 31st. Also note, so this is not applicable to on-campus students or those that will require an F1 student visa. Just as a note too, we do not grant student visas to any online students. So that's why you do need to apply as an on-campus student, and student visa processing can take some time, which is why, we do have a little bit more flexibility for online Dana Viterbi applicants because we don't grant student visas. So for those that want to apply for fall 2022, planning to pursue your program fully online, we do encourage you to still apply as early as possible. We do rolling admission, but before by May 31st, you can still apply. And then for those campus applicants, as well as those that want to start a little bit later, spring 2023 is the next application deadline. That's going to start in January of 2023. And the deadline for the scholarship consideration, now this is only for on-campus applicants, is going to be August 31st of this year. And then the deadline to submit all required materials is going to be September 15th. And then also, if that's too soon, fall 2023, which would be August of 2023, which sounds far away, but not really. The deadline for the scholarship considerations for on-campus, again, only is going to be December 15th. And then required materials is going to be January 15th. With the asterisk there, that again, we do have some flexibility for our online Den and Viterbi applicants. So if you ever get close to a deadline and are wondering whether or not you have additional time, feel free to email Marilyn and I at denofviterbi.usc.edu, and we can work with you on an extension if needed. So in terms of the enrollment options, of course, we have two main options. We have on-campus delivery, which typically our on-campus students tend to go take courses on a full-time basis, taking 2 to 3 courses per semester, depending on, the number of units and what they can handle. And then usually they graduate about 1.5 to 2 years. And then we also have, of course, our online Den and Viterbi delivery, which I'll talk about a little bit more. And because the large majority of our online students are also working full time, they tend to take 1 or 2 courses per semester. Keep in mind, though, that you do not have to be working full time or working at all to be an online student. So this is just kind of typically speaking. And then on average, our online students are graduating about 2.5 to 3 years. But as long as you graduate within the 5-year term to completion, then it is flexible in terms of how many courses you take per semester and whether you take summer courses, which is considered optional. But yeah, you have 5 years, and you can even petition for additional 2 years if needed.
Yeah, just a couple of comments there.
Sure.
One thing that I recommend is that if you want to try to finish, as quickly as possible, and you're a remote student, or even if you're an on-campus student, that if you want to take a course during the summer, it's best to take AME 525, the applied math course, not take it during the academic year, because that's the one course that's like always offered during the summer. A lot of the other courses are not offered during the summer. So save 525 for the summer. If you're not, super anxious to finish as quickly as possible and you don't want to take summer courses, that's fine. But if you want to take summer courses in order to graduate as quickly as possible, don't take 525. Don't fill up your program with 525 in the spring or fall. Wait for the summer. Just an observation. And to be honest, I'm not quite sure why this is the case. That actually over the last 10, 15 years, we used to have a lot of DEN students, maybe about equal numbers of DEN students and on-campus students. But I found in the past few years, we've shifted primarily to an on-campus full-time master's population. A much smaller, in my classes at least, a much smaller number of DEN students than on-campus full-time master's students. I'm not quite sure what to make of that. That's just an observation.
Well, thanks for that insight.
And certainly we prefer, I certainly prefer to, see the students, in my class rather than seeing them, sort of on a screen in the background there.
Yeah, and that's perfect segue. So in terms of how our online Den and Viterbi delivery method works, so of course it's our online method, but students really actually have essentially 3 ways of watching the lectures. So they can watch the lectures live as they're typically happening on the USC campus. Nice thing about that is you can call in your questions, you can chat your questions, similar to this session, and get those on the spot. But then if you're not able to attend those live lectures, or you want to watch it again as many times as you want, you can also watch the lectures on your own time via the course recording. So you can stream those lectures as many times as you need to. It's a great studying tool as well, and you have that until the end of the semester when they're no longer available at that point. And in addition, as Professor Ronney said, it's great to have students come to campus. So you also have a seat in the classroom. You're more than welcome to come to class and engage with the, meet your faculty, meet the fellow students as well. And so that's definitely an option. Although we also recognize some of you may be in a different country across the country, so that is obviously not possible for many. And so it's an option. It's completely optional. You can pursue your entire degree 100% online if that's what you prefer or if needed as well. We have many students that do that. And in
Yeah,
terms of,
but and
go
I'm
ahead.
saying if you're on campus, don't use the fact that the lectures are recorded as an excuse not to come to class, okay?
Yes. And yeah, and then that way too, you don't get behind, right? You don't want to get too behind in your classes and wait, to the end of the semester to watch all your classes that way. But I'm going to go through some of these things on the next slide, but just we get a lot of questions about exams. So during the pandemic, of course, there are a lot of students taking exams, or most students taking exams online. But and generally speaking, the exams would actually take place on USC's campus. And if you're in the Los Angeles, Orange, or Ventura counties, you would take your exams on USC's campus. Now, if you're outside of those areas, then you would take your exams at a proctor location, and it would need to be that's conveniently located close to your home or your work, and you would need to take the exam as close to the time, if not the exact time it's taking place, on USC's campus as well. We do have a dedicated Jenna Viterbi exam coordinator that can also assist if needed with, helping with your location. And if you're ever traveling for work and it's required that you are working during the exam, she can also assist with that as well. And so this gives you a side-by-side comparison. I know the majority were interested in online, at least through the registration, but I did see a number that were also interested in on campus and undecided. So, in terms of the program mission requirement materials, it's exactly the same, no difference whatsoever. Again, so the weekly course lectures, the exams, the homework assignments are exactly the same deadlines. You would, and typically most students do, submit them electronically at this point through whether it's the course management system or, depending on the faculty members and what their preference is. And then, in terms of courses per semester, I talked about that again. And so it can vary, whether you're online or on campus. Degree completion requirements are 27 to 37 units with a 3.0 GPA or above. No difference whatsoever. Just as there's not going to be any difference in your diploma or your transcripts, there would never be an indication that you're an online or an on-campus student whatsoever. You're earning the same exact degree. So just some quick additional information. So in addition to being able to apply for formal admission, we also have an enrollment option called limited status. Now, limited status is a way to get a jump start on taking courses as early as the summer. So maybe you want to take that, 525 AME 525 course during the summer, but you're not yet ready to apply for formal admission. Well, you can do that via the limited status enrollment option, but you do need to have an undergraduate degree in engineering, math, or hard science, and it does need to be a cumulative GPA of at least a 3.0 on a 4.0 scale. So that's actually different from formal admission. As I mentioned before, formal admission, while it's recommended to have a 3.0, it's not a hard requirement, whereas for limited status, you have to have that 3.0 or above. But if you want to get started, so there's a maximum of 12 units you can take as a limited status student, and also keep in mind that you still need to formally apply for admission to a graduate program if you're planning to pursue that and earn that degree. And limited status does not guarantee that you'd be formally admitted. To get started, it's pretty easy. You can just go to the link provided there for more details on how to complete what's called a Jenna Viterbi profile. And again, like I said before, I will send a follow-up email with the slides, so you'll have a copy of these slides as well. for those that are joining live. And then we also have what's called the Employer Reimbursement Deferment Program, and that's for those who's maybe working for a company that is pays for their tuition after, and you can actually defer your upfront payment of up to 90% of your tuition rather than having to pay that upfront ahead of the term. And there's more details there. This gives you an idea what the current tuition structure is for our graduate engineering computer science tuition. So keeping in mind that, that doesn't include some of the per semester smaller fees. The tuition is the same whether you're on an online or on campus student or you're in-state versus out of state. We're a private nonprofit institution, so it is the same for regardless of your location as well. And so we do encourage you to also go to the link for the most up-to-date information, especially if you're reading this or watching this later on. We do have a Den Viterbi scholarship. So this is a scholarship that is separate from the formal admission application. They are merit-based. We have a number of scholarships that are awarded to those that are pursuing a master's degree online via Den Viterbi. So they are partial scholarships that range from 1 to 4 units of tuition, and it's for those that are either receive no tuition reimbursement or partial reimbursement from their employers. The funding is awarded during the academic year, and you can actually reapply each academic year for future scholarship consideration. For newly admitted students or those that have an application on file, as long as you have an application on file, you do have to also have an undergraduate GPA of at least a 3.0 on a 4.0 scale, keeping in mind that this is a merit-based scholarship. And the deadline for fall 2022 is going to be Monday, July 18th. And we encourage you to complete the application as early as possible as well. So to get started, for those that are interested in pursuing their program as an on-campus student, we encourage you to come to campus, or if you're, even on planning to pursue a program online, we encourage you to come to campus and explore the campus. You can do a campus tour, virtual tour as well, depending where you're located. And of course, we encourage you to start your application for formal admission. For those that are planning to apply for spring 2023, which is the next opportunity for on-campus students, note that the application will be available most likely sometime in July of this year, 2022. And then for those that are interested in pursuing the program online via Den Viterbi, of course, you are also encouraged to start your application as early as for the fall 2022 term. And then if you would like to get started, though, as early as the summer 2022, which starts as early as May. Summer, there's different start dates depending on the individual course, but many of the courses start in May. And so we do encourage you to complete the Den Viterbi profile to determine whether or not you would be qualified and approved. Okay, so now is your opportunity to ask additional questions to Professor Ronney. I do see that we got a few in the chat. I'm going to go ahead and ask those now. So, so I'm interested in, from Nicholas, I'm interested in manufacturing automation classes in addition to other mechanical graduate classes. What options do I have for online?
Mm-hmm. Well, we have a number of classes in the manufacturing area. We have, some very senior and a couple of junior faculty in the area with S.K. Gupta and Yang Chen, who are real superstars, real experts in the manufacturing area, and a couple of junior faculty in the area. And they have a whole set of courses of, in that area, automation and manufacturing. So I like to think that that's one of the areas that we have, for a small department. Keep in mind, we are still a small department. 25 tenure track faculty is not a large number. So we can't do everything. We can't be, we can't say we specialize in everything. Well, we have to specialize in just a few things. And that's one of the areas is design and manufacturing, as well as robotics and automation, as I mentioned on one of the first slides, are two areas that we do specialize in. So we have quite a few classes in that area. We have a whole, for the on-campus students, we have a whole Center for Advanced Manufacturing. It's actually such a big facility, it doesn't fit on campus, so it's actually in a warehouse about a mile or so off campus with, all of the manufacturing and robotics type equipment you could possibly imagine.
Great. And then also a question from Robert, what type of propulsion fields does USC teach? Solid propulsion, liquid, electric, etc.
Yeah, so I typed out something in the chat, but so we have that we teach. Now keep in mind, we also have another department. It's called the astronautics department, which is separate from aerospace and mechanical engineering. I mean, we interact a lot, of course, but it is actually a separate department. And we decided that they would teach the rocket propulsion classes. And so they do have classes in all of that in solid, liquid, as well as electric propulsion. We handle the air breathing because we're aerospace and mechanical. If it flies in the air, then we take care of it. And I teach, a senior level course that include, and as well as a graduate course, two different courses that include elements of propulsion from the gas turbine side, that is the subsonic and supersonic side, as well as hypersonic, that is very high speed propulsion, which obviously nowadays you hear a lot of people who'd never heard the word hypersonic before in their life are hearing it now. I mean, as engineers, you know about that already, but now it's become a common word that everyone has heard in the local news. So we really cover all that. Also, we do have within Viterbi, we have the Rocket Propulsion Lab. That's one of the student teams that I mentioned, and they do solid propulsion. But there's also now a liquid propulsion lab, and so they're doing actually LOX kerosene, LOX liquid oxygen and kerosene uh, propulsion, actually building, rocket motors. That. Of course, we can't do that on campus. They have to go out to the Mojave Desert where they have a test facility to actually test those rocket motors.
Great.
Um,
I have another from Abby. Hi, Professor Ronney. I completed my BS degree in aerospace engineering 4 years ago from Embry-Riddle and have been working since then. Can you give any recommendations on fresher course or anything else that can help prepare for the master's coursework? Thank you.
Sure, it's a great question. I think one thing I would do, I mean, of course, the obvious answer is, well, review the courses that you've taken, your lecture notes, etc. One thing I find that's very helpful to students is to try, even though look at your homework assignments and your exams, read through the solutions. Okay, after 4 years, you're not going to remember, and then try to do those problems again without looking at the answers. Now, yes, you have the answers in front of you, but it's one thing to look at the answers and say, "Oh yeah, I understand that. I understand that. I understand that." It's another thing. So when you're seeing, say, this side, but when you're just seeing the question and not the answer, it's a lot harder, right? So see if you can do that. The other thing I would say, so besides reviewing what you've done in the past, I would also say, well, try to think about what courses do you think you'd like to take, and then uh, ask the instructor of those classes, do you have sample homework assignments or exams, that I could use as a basis for studying? Like, in my class, I have like all of my homework assignments posted online. I don't post the solutions online, but I post the questions themselves online, and then I will have a sample exam from a previous year posted online. So you're welcome, at least in the case of my classes, you're welcome to look at those. Um, and, I don't want to offer this necessarily to everybody, but to say if you work through those, put it this way, if you take the time to work through those, then if you want to send them to me, I'll sort of say, yeah, okay, you got this part right, but this you got to think about something else here. I might, again, that could wind up taking a lot of time, but if I can, if in limited cases, I can even tell you, yeah, okay, you did, your answers are kind of okay here, but think about this other thing. So I think that would uh, give you a good head start to refresh your skills in that. I do, though, advise a lot of students will say that, oh yeah, that I want to, I want to take a few years off and work and then go back to school. I don't really think that's the best idea. I know for some of you, you have to because of your personal situations, totally understandable. However, ask yourself this. Have you ever heard an athlete say, I'm going to take a few years off from my sport and then come back to it, right? No, you never heard any athlete ever say that. And being an academic is to some extent, being like an athlete. If you don't use your skills, if you don't keep training, you're going to start to lose your skills. So if at all possible, I recommend that you just blast through and continue. Okay, see, we have some other questions coming up.
Yes. This one from Michael. How would you go about determining a
Okay.
specialization? I have a lot of interest, but not exactly sure which is my one of
Mhm.
which one is my favorite.
Sure. What I would suggest then is you, at least in AME, and as a department chair, I push hard on all of our faculty for all their classes to make sure that their syllabus is posted online. So go look at the syllabi of the classes that you think you might be interested in. And if that's not enough, you could certainly, again, try to see if you can find some online, um, either course materials, either lecture notes as I publish, or again, sample assignments and such, or if necessary, even go and talk to faculty about that. The other thing you can do is in the first week of classes, just sit in on the class. I always get students saying, I'm not sure if I want to take your class, or even students say, I'd really love to take your class, but because I'm already, kind of on overload in terms of units, I can't actually register for your class. Is it okay if I just sit in on it? I say, someone who wants to sit in on my class, it doesn't have to. Of course you can. So
Yeah,
by all means, um, you know, I say this is, as I said before, this is a university. The root word is universal. Just, try all those things.
great. I have another one from the chat. Do you have any mechanical programs that emphasize hardware software interface? Or would this be in a department other than mechanical?
Yeah, this is actually something that we don't really have that much of, and I'm actually trying to change. Now, at the undergraduate level, I think we do a very good job of that. That is, we have the students there get a lot of hands-on experience. They have a junior level class in basically, it's called mech optronics. So it includes sort of instrumentation and how to build electric circuits of the type that you would use either to acquire data from an experiment or to control an experiment. It's a very, very intensive class. I'm trying to create a graduate version of that class. Uh, we don't have it yet, so it wouldn't be available in this fall. It might be available, say, by fall of 2023. But that's one thing I'm working on because, that's something I think that we don't have enough of at the master's level. We do have a couple of courses, though, that do include, hands-on lab components. But of course, if you're going to do that, you have to be an on-campus student.
Gotcha. Okay, and I have one last question here. I am an aerospace engineering graduate from Embry-Riddle as well. I'm curious about the letters of recommendation. I'm interested in the product development masters and was wondering if a letter from my design lead slash manager at Boeing would also be relevant outside of any academic recommendations.
Yeah, that's a great question. You're right. That's one case where I think, because you're talking about product development, that's very, very focused, in industry as opposed to the academic side of things. So yeah, I think in that particular case, if you really have a sort of industry focused emphasis, like say product development, then yeah, I think in that case, a letter of recommendation from your supervisor would be very appropriate.
Great. All right. So with that being said, I know we've come to the end. I know that if you have any other questions, these have been fantastic questions, but we do encourage you to ask them. If you are interested in pursuing your program as an on-campus student, you'll go to that particular contact information. And then for those that are interested in pursuing their program online via Deneviterbi, feel free to reach out to Marilyn or myself at deneviterbi.usc.edu. We do always make every effort to respond within a 24-hour window during business days. Or you can, set up a call with us as well. Happy to answer your questions that way. But thank you so much, Professor Ronney. This has been super
Thank you.
insightful. I really appreciated hearing everything from you, and I'm sure the audience has as well. Thank you all for joining us today. Have a great rest of your day. And as we say at USC, fight on,
Right on.
fight on.